Okay, number 9 says let f and g be the functions given by f of x and g of x, and let R be the shaded region in the first quadrant. First problem says find the area of A. So to find the area, I need to draw a rectangle and find the area of the rectangle. Well, the area, the base is dx, and the length is the top minus the bottom, which would be 1 plus sine of 2x minus e to the x over 2. So the area is going to go from 0 to this point, which is my point of intersection. So what I did is I graphed these in my calculator and calculated the point of intersection, and I called it A. And A was 1.1356. Remember that on your calculator, you have to store it because you have to use all the numbers, not just 4. So I'm going from 0 to A of my length times the width. And that is 0.4291. Part B says, find the volume if the solid generated is revolved around the x-axis. Okay, so we're going to revolve this region around the x-axis. Okay, so it's going to look somewhere over here. So notice it's going to be a washer. Okay, I'm going to have my small disc. Okay, and then I'm going to have the bigger disc. So this is going to be, to find the volume, I'm going to go from 0 to A again. So I need to find the area of the big circle. So remember, the area is pi r squared. So that's where we're going to get our pi. The radius of the big circle is the top minus the bottom. So it's just going to be 1 plus sine of 2x squared minus the radius or the area of the small disc. So it's going to be, again, top minus the bottom, e over x squared squared dx. And that turns out to be 4.267. Okay, part C says the region R is the solid of the base, but this time we're going to have cross sections perpendicular to the x-axis that are semicircles. Okay, so basically these right here, cross sections, they're semicircle. So here's my semicircle. So the area of the semicircle is pi r squared divided by 2. Well, this is your diameter. So your diameter is the top curve minus the bottom curve. Okay, so the radius is going to be half of that. So my area is going to be pi over 2. The radius, which is my diameter, divided by 2 squared. So that is the area of one of these semicircles. So to find the volume, again, I'm going to go from 0 to A of pi over 2 times 1 plus sine of 2x minus e to the x over 2 squared, divided by 2 squared. And don't forget your dx, because that would be the height of your of the semicircles, and that turns out to be 0.07765.